This video will cover the SN2 reaction. The characters SN2 stand for second order nucleophilic substitution. It is a substitution reaction because the incoming nucleophile replaces the leaving group on the substrate. It's nucleophilic because it involves a nucleophile, and it's second order because both the nucleophile and the substrate are involved in the rate determining step. The general reaction of an SN2 looks like this. It involves a nucleophile and a substrate, the electrophile, which is often an alkyl halide. In this case, the halide acts as the leaving group, and the nucleophile replaces the leaving group. This is why it's called a substitution reaction. The products of this reaction are the substituted substrate, now containing a new bond to the nucleophile, and the leaving group, which is left with the bonding electrons, giving it a negative charge. Now, let's consider the mechanism of this reaction. In this reaction, the nucleophile attacks the electrophile. The most electrophilic atom of the substrate is the carbon that's attached to the halide. Remember that the carbon-halogen bond has a bond dipole pointing in the direction of the halogen. This gives the carbon attached to the halogen a partial positive charge, making it very electrophilic so that the nucleophile wants to attack. Once the nucleophile attacks and forms a new bond to carbon, that carbon must now lose a bond because it cannot have more than 4. It loses the bond to the leaving group. This mechanism goes through a transition state where the bond between the nucleophile and the carbon is forming and the bond between the carbon and the leaving group is breaking. That looks like this. Remember that the transition state is the highest energy point between reactants and products. As the reaction proceeds, the bond between the carbon and the leaving group breaks, and the bond between the carbon and the nucleophile forms, giving us the products observed above. Now let's look at an example SN2 reaction. We will use hydroxide ion as our nucleophile and iodomethane as our substrate and electrophile. The products of this reaction will be methanol and the iodide leaving group. The mechanism of this reaction will involve the nucleophile attacking the carbon of the electrophile and kicking off the iodide leaving group. This mechanism will go through a transition state where the hydroxide carbon bond is forming and the carbon iodine bond is breaking. Notice that the nucleophile is donating a pair of electrons to form a new bond between the oxygen and the carbon. The electrophile is accepting those electrons to form a new bond. The final thing to note is that we have drawn a one-step mechanism that is second order, first order in each of the reactants, and this is supported by the kinetic data. If we double the concentration of either reactant, the hydroxide ion or the methyl iodide, the rate doubles. That tells us that the rate is first order in each reactant. Because the rate is first order in each reactant, it is second order overall. This is where the 2 in SN2 comes from. In other words, this means that both reactants are involved in the mechanism of the rate determining step, which is also the only step of this mechanism.